Hello everyone, this is Martha once again, and this video is going to be about graphing logarithmic functions or graphing logs. So let's jump right in. We're going to look at how to graph a log also in relation to exponentials because they're inverses of each other. So this first graph on my left is we're just going to cover when an exponential function y equals b of x, when that has a b that's greater than 1, it hits that point at 0, 1, right? So, and there's this horizontal asymptote along the x-axis. And as it crosses and it goes up and to the right and up, but as it goes to the left, it gets closer and closer and closer to 0. And so that's what the exponential function looks like. Now, because they're inverses, let's flip it over this line of y equals x. That's kind of what happens. So, and the log hits the basic parent function of log hits at 1, 0. But it has a vertical asymptote of the y-axis. As it gets closer and closer and closer to 0, or as it goes left, it goes down. And as it goes right, it goes up. And this is our basic y equals log base x. This is kind of the parent function of which things are based off of. And knowing our asymptotes and knowing the point where it hits the x-axis is pretty important. Now let's take a look at the exponential pattern when your b, or your base, is between 0 or 1. So when it's a fraction, when it's a decimal, and so it still hits that at that point 1, 0, 1. There we go. And it still has the horizontal asymptote as the x-axis. But as it goes to the right, it gets closer and closer and closer to 0. And as it goes to the left, it goes up to infinity. And this looks a little different, but it still gets flipped over that line of y equals x. And the log function, when your base is between 0 and 1, still hits at the point 1, 0. And it still has a vertical asymptote of the y-axis. So let's draw that in. I'm just doing it with dashed lines. And the difference here is as you go left, as you get closer to 0, it goes up. And as you go right, it goes down. So we're going to keep these parent functions up as we talk about some transformations. And a lot of these are pretty similar to what we've done before with other translations, so let's hop in. The top box talks about the vertical, right? Up and down along the y-axis. And if we have our base, or our log function of log some base x, if we have plus c, the point moves up. That point of 1, 0 moves up that many units. If we have minus c, it moves down that many units. So just a quick example of this might be if we have log base star x, we're still going to hit at 1, 0, and it's going to look like this. But let's find a different color. Log base star x plus 3. So we take and we move this up 1, 2, 3, 4. So I use 2 spaces. So 1, 2, 3. So our new graph looks like this. It follows the same pattern of it gets close as we get closer to 0, it goes towards the asymptote. If not, it goes out to infinity. So if we have a plus or a minus, a number, and it's outside of the parentheses with the log, then it's up and down. It's a vertical translation. Now next, we're going to be talking about horizontal, or along the y-axis. And this, we can tell the difference because it's within the parentheses. If we look, we've got x plus c. That plus c is attached to the x inside of the parentheses. It's not outside. So and also, if it's plus c, we go to the left. To the left now. And then if it's minus c, we go to the right. And in this instance, it's also important to keep track of that horizontal asymptote. So let's graph this. This is our function again, where we hit 0, 1, or 1, 0. Thank you. This is kind of what our parent function looks like. Now let's see if we can't graph log base star and then x minus 1. And we've got that minus 1, so we know we're going to move 1 to the right. And we're going to hit at 2, 0. But our asymptote also moves along with it. So our asymptote is now x equals 1. And our graph as we go right, it goes down. Or sorry, as we go left towards 0, it goes down. And as we go right, it goes up. So that is a horizontal translation when the plus or the minus is inside the parentheses with the x. They're just hanging out together. And if it's plus, we go to the left, and if it's minus, we go to the right. Now we're going to talk some reflections. And reflections is when we flip it about an axis. And for this one, the negative is where it happens. If it's negative log some base x, it's going to flip around the x-axis. And if you've got a positive log some base, but the negative is inside the parentheses with the x, it's going to flip along the y-axis. So let's take a look at that really quickly. So we're going to quickly draw in our parent function, where it hits at 1, 0. Looks like that. Now let's graph negative log whatever base and x. But this time, because it's flipped across the x-axis, because we've got that negative, as we go towards our asymptote, it goes up instead of going down. And as we go towards infinity, it goes down instead of up. And that happens, again, when the negative is connected, when the negative is outside of the x, or outside of the parentheses. And we're going to do a reflection about the y-axis. So we've got our parent function here, hits at 1, 0, goes up. Now let's look at log base smiley face, because it doesn't matter what the base is. X, but it's minus x. And so we're going to flip everything across the y-axis. So our x's become negative. So instead of hitting at 1, 0, we're going to hit at negative 1, 0. And it follows the same pattern. As it gets closer to 0, it goes down. And as it gets bigger, it goes up. And the last two things that we're going to talk about are stretching and shrinking. And for time's sake, we can't go over these in great detail and graph them out like we did before. So I'm just going to write it out here. Now it's vertical, stretch, and vertical shrink. And this is how that happens. If we have c, or some number, log whatever base in x, if that c is greater than 1, if that number is greater than 1, it's going to stretch. Zoop. And if that c is between 1 and 0, so if it's a fraction or a decimal, it's going to shrink. Now what about the horizontal stretch or shrink? And if it's the same, but this time we recognize a horizontal stretch and shrink, where if we've got y equals log a star, and then we've got our c hanging out with the x, so it's some number with the x. Now it's going to shrink or get smaller if c is greater than 1, and it's going to stretch if that c or that number is between 1 and 0. And this can be a little frustrating for students sometimes. And the best way I know of to kind of get it straight is just some practice. It becomes more intuitive and when you practice, look at why, and try and think of why your x's or your y's are changing and how that impacts the shrinking or the stretching. Well, I hope this video helps, and have a great day. Have some fun.